order to solve, there's because we have two different kinds of equations we're dealing with. We've got exponential equations and we've got logarithmic equations. So let's solve exponentials right now. Okay? Now, as you probably are aware, I'm kind of a big step guy. Okay? So the steps to solving an exponential equation are actually the same steps that you're going to use to solve a logarithmic equation. Almost a logistic equation, but we're not doing logistic functions. Okay? All right? So the first step is you need to isolate. So if it's a logarithmic equation, you would isolate the log term. If it's an exponential equation, you would isolate the exponential term. Okay? So in this particular problem, this is the exponential term. I need to get that by itself. Okay? Only thing on either side, I don't care which side it goes on, but that's the only thing that needs to be on there. So that would be a plus 4. So that gives me then 3 to the x power equals 10. Yes? Okay. All good in said hood. Okay. So that's isolated. Step number 2 then is you are going to switch forms. So if it's an exponential, you're going to solve it by switching it into logarithmic form. If it's a logarithmic equation, you're going to switch it into exponential to solve it. Okay? Okay? So we switch forms. So this is an exponential. So now I'm going to switch forms with it. So that's going to be log base what? Of equals once we've switched forms, now we solve. Okay? So I want to solve this for x. Now when we solve, I will tell you that we are going to we're going to round to 3 decimal places whenever possible. Okay? Okay? So now we've got to solve this one. So we need to figure out what log base 3 of 10 is. Well, is there an exponent that I can put onto 3 to get me 10? No. So that means we're going to the calculators. We're going to use change of base. So this is either going to be log of 10 divided by log of 3 or natural log of 10 divided by natural log of 3. I get 2.0959. Let me make sure. 59032742894. Okay. Right? Rounded to 3 decimal places, that would be then x equals 2.096. Yes? Okay. Now, how do we check that? Because that's step number 4. We have to do this check. Yes, ma'am. And do what? say 3 to that power and then I'm going to hit equals, and then I'm going to subtract 4, and I get 6. Okay? If I rounded it, if I went 3, I kept mine exact on my calculator. What do we say, 2.096? And then minus 4, I get 6.00106. But again, because we rounded it, that's why my answer is fairly close to 6. Okay. Then, once I've checked it, now, it'd be done. Good? Questions, comments, concerns, clarification, haikus? Alright? I would like you to solve those 2 equations for me. Please. First one, isolated?
Yes.
Yep. So we can switch it right to log form. What is log base 4 of 54? Going to be something a little bit less than 3. I get 2.877 there. Then if I subtract 2, I get 0.877 there. Then if I divide by 4, I get let me go down a little bit so that we can actually see this. I get 0.219. If I check it, that times 4, then add it to 2, then I take 4 to that power, I get 54. Checksum. Yes? No. On this particular one, add 3. Divide by 2. Switch forms. Log base E is natural log. So that's why we get natural log there. Add 2. Oops. So then, I lied, subtract 2. So then this would be negative 3x equals the natural log of 7 minus 2 is negative 0.054 divided by negative 3. Oops, I forgot a 0 in there. If I take that times 3, 2 minus that, e to that power, times 2 minus 3 gets me 11. Yep. Questions, comments, concerns, onomatopoeias? Good? Yeah. when we're solving single log equations, the steps are the same. Isolate, switch, solve, check. Okay? The steps are the same, but there's 3 different forms of logarithmic equations. So this is the first one. So isolate is the first one, so I would subtract 3. That gives me log of x minus 3 equals 2. I have now isolated the log term. Okay, all I've got is the log term on that side, so now I need to switch forms. What is the base of this logarithm? See who was paying attention. Yes, the base.
All time
10.
10.
Yep. When the base isn't written, it's 10. Okay? So then this becomes 10 to the second power equals x minus 3. 10 squared. Ten times 10? 100. Add 3. And I get 103 equals x. 103 minus 3 is 100. Log of 100 is 2. 2 plus 3 is 5. And there is my answer. Okay? Same steps. Go for it. Try it. Isolate, switch, solve, check. Isolated, not isolated. Isolated, yep. Okay, so then we switch. So it becomes 4 to the 6th power equals 3x. 4 to the 6th power, what's that? 4,096? Oops, equals 3x. Then we divide by 3. Unfortunately, 4,096 is not divisible by 3. So that just means we leave it as 4,096 over 3 equals x. Then we check it. Well, 4,096 divided by 3 times 3 is 4,096. Log base 4 of that is 6. 6 is equal to 6. Bada bing. Bada boom. We switched forms with it. Now, had you been able to watch your It's Learning last night, we had second form of logarithmic equations is when you've got log equals log. Okay? Now, log equals log ones are nice. Especially if the bases are equal. That's your first check. You first got to check that these bad boys right down here are the same. Okay? If those are the same, then, so the logs are the same, the bases are the same, that means that the arguments have to be the same also. So these two parts have to be equal. So you just say 2 minus x has to equal 5x. Add x to both sides. Divide by 6. One-third equals x. Check it back. 2 minus 1/3 is 5/3. 5 times 1/3 is 5/3. Log base 7 of 5/3 is equal to log base 7 of 5/3. Questions, comments, concerns, clarifications?
So, if they share a base, if the base is the same, then they just cancel? Okay.
It's no different than if we had like 2x plus 7 equals, 2x minus 7. Or not, I shouldn't say it. Let me say it this way. It's no different if we had x plus 7 equals 2x plus 7. These plus 7s cancel each other out.
Okay.
Right?
Yeah.
So these log base 7s cancels out the log base 7s. Okay? Same thing with natural logs. If it's natural log equals natural log, then you just set the arguments equal to each other and solve. Go for it. So 5 minus 2x has to equal 5x plus 3. Let's add 2x. Subtract 3. Wrong color. Oh, 5 minus 4/7 is 4 3/7. Why would we plug it in a calculator? So that's 31/7. And then we got 10/7 plus 21/7 is 31/7. Well, it is. Because 5 is 35/7. 3 is 21/7. What's up?
So you ever have a situation where the logs or the natural logs aren't the same base, but they're still equal to each other?
No in the natural logs, because natural logs are always base e. Okay? Possibly in the regular log case, but you'd have to be in a much higher level math class in order to get that. So in here, but yes, it is possible. Alright? So, the other one is when you've got 2 or more logs and then you got a bunch of extra stuff. Okay? So on the last 2, we had 2 logs. We didn't have all the extra stuff. But if you've got extra stuff, then it's a whole different ball game. Okay? And so the first thing that we have to remember is we have to remember back to our 3 properties of logarithms. Okay? The first one is the product property. And the product property says that if I am multiplying something in here, in my argument of my log, I can split that up using addition. So I can take this argument and I can make it become log base b of m plus log base b of n. It's called expanding when you work to the right. All three of these properties also work going to the left. That's called condensing, because you're taking multiple logs, condensing it down into smaller, or one log. Okay. The quotient property, so now we're dividing by something, and so then that's the opposite of multiplication, or the inverse of multiplication. So the inverse of addition is subtraction. So again, the quotient property, I can take this and I can break that up into log base m, or log base b of m minus log base b of n. Power property says that I can take an exponent and I can bring it out in front of the log, or if I'm condensing, if I've got something multiplied, I can put it back into the argument as the exponent. Okay? Now you spent an entire chapter just based off of these three properties back in Algebra 2, so that's why I figured that I can just give it to you here in the last 5 minutes, okay, of me speaking. Okay? Because you should have this stuff, at least a knowledge of it. We're not going to go high intensity into expanding and condensing logs. Okay? We're going to use it basically to solve. Okay? So let's put it to good use here now. Okay? So here in this particular case, I've got 2 logs, but I've also got an extra number that's not part of the log. So that's extra stuff. Okay? So I can't just say log base 2 of x equals log base 2 of x plus 1 because I've got that extra 1 hanging out there. So what I'm going to do is I am going to condense this log into 1. So since I'm adding here, that means that I would be multiplying in my argument. So those 2 logs condense themselves down to log base 2 of the quantity x times x plus 1. Now I have a single log equation. So if we go back to what we started with today, we need to isolate, done, switch forms, solve, and check. Okay? So if I switch forms with this, my base would be 2, my exponent would be 1, my argument is x times x plus 1. Good to go so far, Rat? Love it. Rat, can I ask you a personal type question? What's 2 to the first power? 2. Love it. Can I ask you a follow-up question to that? What's x times x plus 1?
X squared plus x.
What's wrong? We so can solve that. Set it equal to 0 next. Yes, because we have a squared term. Factorable?
Yes.
To what?
X plus 2, x minus 1.
What if it wasn't factorable? Quadratic formula. Yeah. Yeah. Now what? Nope. Don't.
Set each factor equal to n.
answers? You gotta check them. Where do I go about checking them? Into my original equation, right? Okay. So if I go with negative 2 here, I get log base 2 of negative 2. What is log base 2 of negative 2? What do you got? It is not 1. What is log base 2 of negative 2? We'll see who was paying attention yesterday. We had 2 rules yesterday. What were our logarithmic rules from yesterday? Nope. The base can't be negative or equal to 1. And what's always positive? B in the number, right? So what's my B in this case? 2. That's positive. What's my number in this case? Is that positive? Not possible. So negative 2 gets kicked out. Now we got to check 1. Log base 2 of 1. What exponent can I put on 2 to get me 1? 0. So that's equal to 0. Plus log base 2 of 1 plus 1. What's 1 plus 1? 2. Log base 2 of 2. What's that equal to? What exponent do I have to put on 2 to get 2? 1. 0 plus 1 is 1 equal to 1. Checks out. So negative 2 got thrown out. So it's just x equals 1. Yes, ma'am. Because otherwise, you know what I mean? Yeah.
So the words that you did on the side, you have to show.
How else do I know that you did it? You know what I mean? Because you got to do it because one of them got thrown out. And I know if this were a test question next week, Friday, somebody would give me negative 2 and positive 1 and know for sure that they're right. Because they just didn't check. You know what I mean? Because we got them both, but one of them is extraneous. Oops, I think we're done. Look at that. We'd be done. Homework tonight is another worksheet. What do you think? Laney, what do you think? Monday? Monday? How many problems do you think this one is tonight, Laney? 8. Monday? I think we can handle Monday.